Hello there, pre-algebra students. Welcome back to another episode of Chow Time. Today, we're looking at Lesson 4, Properties of Numbers. If you're following along in the book, this will start on page 19. Our vocabulary for the day: properties, a statement that is true for any number. I'm going to just take a second to remind you that vocabulary words in different classes, even though the word might be the same, they mean different things. So in the context of math, properties means one thing, but in the context of chemistry, properties might mean a completely different thing. Okay. Our next vocabulary words: commutative property of addition and commutative property of multiplication. They both basically mean the same thing, and that is the order in which numbers are added or multiplied does not change the sum or the product, and this only works when you're dealing with only addition or only multiplication. Now we have the associative property of addition and multiplication, which is the way in which numbers are grouped when added or multiplied does not change the sum or product. And again, this only works when you're dealing with all addition or all multiplication. And just to give you an example, 2 plus 3 in parentheses plus 4. This is the same thing as 2 plus, and then in parentheses 3 plus 4. So the way that the numbers are grouped can be changed, and it does not change the sum. And the same thing works with multiplication. 2 times 3 times 4 equals 2 times 3 times 4. Oops. Then we have the additive identity. The additive identity means that when you add 0 to something, you get the same thing. Nothing changes. The multiplicative identity means that when you multiply something by 1, you get the same thing. It's the same identity. And lastly, the multiplicative property of 0. This is when you multiply something by 0, you always get 0. And our last vocabulary word on the slide: counterexample. An example that shows a statement is not true. And we'll look at that in just a second for you to understand that a little bit better. Example number 1. Is division of whole numbers associative? If not, give a counterexample. And what is a counterexample again? An example that shows a statement is not true. So how do we know if division of whole numbers is associative? Well, let's take a look. 27 divided by 9 divided by 3. Does that equal 27 divided by 9 divided by 3, where we have two different groupings? Well, let's do the first grouping. 27 divided by 9, that equals 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 27 divided by 3 is 9. No, these two things are not equal. So this is a counterexample to the question, is division of whole numbers associative? We know that it's not, because here is an example of it not being. Because remember, in our other properties, it's a statement that is true for any number. So when we're looking at the commutative property of addition, which is talking about the order of numbers, 2 plus 3, this is going to equal 3 plus 2. It doesn't matter what order you write these in. Both are going to be 5. And you're not going to find a counterexample for this. you're not going to be able to find an example of that not being true. So let's look at the got it problem then. Is subtraction of decimals associative? If not, give a counterexample. So let's take a look. Associative means that we can group them in any way we want, right? So 7.3 minus 2.1 minus 5.5. Is that going to equal 7.3 minus 2.1 minus 5.5? Well, 7.3 minus 2.1 is 5.2 minus 5.5. So we're going to see if that's equal to this. Well, 2.1 minus 5.5, 5.5 minus 2.1. Oops. I wrote that in reverse. That's funny. Okay, let's try that again. 2.1 minus 5.5. 1. 11 minus 5 is 6. 1 minus 5 is negative 4. Right, so negative 4.6, is that right? No. Yeah, okay. Negative 4.6. 7.3 minus negative 4.6. So that means that this is a plus 7.3 plus 4.6. 5.2 minus 5.5 is negative 0.3. 7.3 plus 4.6 is 11.9. These are not equal. So here's a counterexample. Name the property shown. Okay, well, d plus 0 equals d. If you add a 0 and it's the same number, then you have the additive identity. 2b. 8 times 1 equals 8. If you multiply a number and it remains the same, that is the multiplicative identity. Okay, here we have a grouping of 9 plus 10, and then here we have a grouping of 14 plus 9. All the numbers are the same in the same order, so we're changing the grouping, which is the associative property of addition. All right. Here we have 5 times 7 times 2 equals 7 times 2 times 5. We've changed the order. Changing the order is commutative. And, oops, property of, we're talking about multiplication here. Okay, so let's talk a little bit about some of these words to help you maybe memorize them a little bit better. Commute means to travel. For example, I commute to work. I travel to get to work because I don't live in the building. So commute means to move around. If you move things around, that is the commutative property. Associate means who you hang out with. I associate with nice people. And so here we have 9 hanging out with 10. Here we have 14 hanging out with 9. This is who I hang out with. That's who I associate with. Okay, so anyway, I hope that helps you a little bit. Identity just means self, right? Me, myself. The self does not change. D is the same, 8 is the same. Next, more vocabulary words. Simplify, to perform all possible operations. So if we have 3 plus 4, and we simplify this, that would be 7. We have no operations now. Or if we have 12 over 14, we can divide both of these numbers still by, what is that, 2? That would be 6 over 7. Deductive reasoning, reaching a valid conclusion using facts, properties, or rules. Interesting. Let's take a look at an example of that. 12 times 10 times z. So we have to do what's inside of the grouping first. 10 times z, well, we can't do that, right? So we can just change the grouping to be 12 times 10. Now, I don't like using the dot, so I'm going to actually draw over that. And then I'm going to put a z out here. So that would equal, here we'll just do that, 120z. Now we have simplified it. Here, b times 0 is 0. 0 times 11 is 0. Here, we can change the order of these two. So that's w plus 15 plus 16. And then we can change the grouping so that it's w plus 15 plus 16. And that's 31 plus w. We cannot do any more operations. That's simplified. 10 plus p plus 18. We can change the order of these two. That would be 18 plus p plus 10. And then we can change the grouping. 10 plus 18 plus p, 28 plus p. Now you might ask, why do this in 2 different steps? Well, these are 2 different steps, right? Because remember our previous vocabulary word, which was deductive reasoning, which is reaching a valid conclusion using facts, properties, or rules. And that's what we're doing here. What rule are we using? We can only go from here to here. I mean, in your mind, you might be able to just use mental math and just go straight to here, right? And that's fine. But what I'm talking about here is, how do we actually know that we can do this? How can we deduce that? Well, we can do it through these facts, through these properties. What property are we using here? This property is the commutative property, of addition, and then here we have the associative. Commutative, associative, and then here we just evaluated. All right, hope you enjoyed. See you soon.